Hi, today we're going to do question 7 of 9702, paper 1-3 of May-June 2023. The question says a device for spraying paint consists of a box with its faces horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meters per second through 400 holes, each of area 0.4 millimeters squared. The density of the paint is 900 kilograms per meter cubed. What is the horizontal force required to hold the device stationary as it ejects the paint? Well, obviously, the paint is ejected through these holes, and that's going to make that's going to provoke a force on the air, and the air is going to push the force backwards. So we need to keep it stationary. We need an equivalent force to that one. Okay, so we have to calculate that force. How do we do it? All these exercises are done the same. When we have areas and when we have velocity, take a look at this. Well, if we have density, we can express density as mass divided by volume. Mass equals density times volume. So we know that the resultant of the forces equals mass times acceleration. So, and mass can be expressed as density times volume. So we know that the resultant of the forces is density times volume times acceleration. And acceleration can be written as velocity divided by velocity over time. Okay, so we're going to express the volume as the area times distance. So then we have that the resultant of the forces equals density times area times distance times velocity divided by time. And take a look at this. Distance divided by time is velocity. So we can express this as sum of forces equals density times area times velocity squared. So now we have everything that we needed here, because we have density, which is given, area, which is given, and velocity, which is given. Okay, so basically you have to obtain a formula with the things that you need, which is the force, expressed by the variables that they give you. And you've always got to play with this, the density and mass times volume, and then always remember that you can change area volume as area times distance, and then play around with that. Okay, the resultant force equals the density, which is 900, the area, which is 400 holes, multiplied by 0.4 millimeters squared. So in order to change it to meters squared, we have to divide it by 1000 squared because it's squared meters, and then multiplied by 2.5 squared. So we have that the resultant force equals 900 times 400 times 0.4 divided by 1000 squared times 2.5 power 2. And if we do that in the calculator, we get 0.9 newtons. So the paint pushes with a force of 0.9 newtons, so the resultant force of all the holes is 0.9 newtons. So that's what we need to in order to hold it stationary. And the solution is the B, which is the one that is given in the marking scheme, so that's correct.